And yeah, and I have to introduce Odilo Schoch.
Not to all, some know me.
A lot of you maybe know Odilo, who actually was a former colleague of ours here at the Royal Danish Academy of Fine Arts School of Architecture, and now you're at ETH. And when you first came to Copenhagen, you were to take care of BIM. And I think in very short time you got the nickname Big BIM, because there was a PhD student who came later who was called Little BIM. And I know that you know a whole lot of it, and you also know a whole lot of Danish architecture and building structure, being an architect yourself. Please welcome Odilo Schoch.
Thank you. And it's really a pleasure to get invited to talk. As you have heard by my question, I like the opposing opinions to some topics. First of all, a question: who's student here in the room? Not that many. Thank you. It's me. So it was a brilliant introduction before. When Anna wrote me, it's about detail, and the detail is that for me it is architecture is to join different systems, building elements in order to make a construction, a building, a bridge, whatever, wastewater treatment plant, whatever it is, an underground metro station. You need to be able to connect things. And it sounds now a bit arrogant, but I think we need to have some really understanding, and it is about this financial understanding, about the material itself, and about the structure, how things go, so that you can have a dialogue with yourself, that you can have a dialogue with your collaborators, and such as like your client, someone pays you. We are rarely those who really initiate a project and have the cash. So the problem is we need to have the knowledge. Did you ever learn how much is this door to buy? How much is it? Okay, that's the problem. So where do you get it from? From these old guys or from the internet? But then you don't have a trustworthy setup. And joins, I like this airport a lot. It's Tegel, Berlin Tegel, and you see it's connected and so on, and it's worn out. It's 40 years old or a bit older even, and it is just, you know, it's about the joint. It's so not the smoking, the joint, the you have to consider here the window, the handrail. People are not falling down, and but it's as well this here. You need to be able to connect things, and this is the refurbishment of a building quite close to here. It's actually my hotel, Nyhavn 71, and someone had to solve that problem. And I'm sure it's not only one person, and this is the main message today. And of course it links to a digitalization, whereas actually the digitalization, it's not like that special, because we are living in it. We simply need to accept it. It is like, ooh, it might be new for us, older generation, but you guys grew up with a touch phone. You don't know the era of a disk-turning phone anymore. You grew up when the World Wide Web was already there. And so why do I mention this? We need to have an understanding how are things made together. And there's my huge critique to as well what we learned the last 10 years about digitalization. And at the same time we need to face that there is still necessity to discuss. Some people might know this building, and I've been really happy to find that illustration on how the office, in this case Peter Zumthor, it's the spa in Walz, Swiss architect, Swiss building, that there's some logic in this. You know, each layer of this natural stone has a different rhythm, but there's a certain logic in it, quite nice. So it's a system. Systems help us to handle sometimes complexity. And I will explain you a bit about how we made that building. That's my office. not the whole area, but I'm sitting over there. And Ena, what's her family name? The Danish, there's one PhD. She studied here, she's sitting there. From Kunstakademie, working in this office as well, so people can go abroad to learn new stuff. It's possible. And what did we do here? We made this building with a robotically fabricated roof. Just for us humans, we make a geometric visualization. All the other things were just code. What did we do? We did, of course, ask for the BIM stuff and this informed 3D models from the MEP engineer, from the architect. We were the architects ourselves. And we all failed with that because we didn't say what we need it for. So, you know, it is not that we just have now data around and then we can merge that and in the end we have a brilliant building. No, we need to have a design intent. And the design intent is probably based on a necessity. And I do agree, we architects would have the potential to take the leadership. So what I missed often today is who is taking the leadership. And Horst, you mentioned it directly. Well, I control the cost because that's your contract. And you could feel people were a bit getting disappointed. So they were like, okay, he talks about cost. Yeah. He talks about cost reduction and all that stuff. Yeah, but someone needs to take the leadership. Why don't we do it? So I'm not joining this club of the disappointed architects. None of you were, because you are all still in your profession. But I want to join the club of opposing these overall trends, and you will soon see my real enemy. As usual, we need to have a bit of the foundation, and my foundation, I will tell you about this, linking to what we could actually do with what real foundation which we should need and often have already is design processes. So some of you might know this drawing. For those that don't know it, I make a shortcut. It is 1200 years old. It's the St. Gallen monastery plan, and it's really old. It is almost exactly 1200 years old. You still see that it is a floor plan. Even the hash over there and the stairs, it's just missing the arrow. Where's the stair going up? It's amazing. And we still can read it. But at that time, we didn't have that much the central heating, ventilation, and artificial light. So we needed to have this technical installation stuff. Someone is expert in that. So we developed the experts. We cannot have the building master in the way that we read it out of the history books. But we can have someone who integrates them, and that's actually a common environment, a common social environment, a common communication environment, and a common data environment. These are these common setups. Because what came out in the last 25 years of BIMing, BIM method application, BIMing to make it short, is that this one no one understands, not even the MEP engineer. So they decided, okay, let's make a 3D model out of that. And that's the problem. Now we think we can use software, have a 3D model, and a byproduct is the 2D section, floor plan, and so on. But you see the difference. This might be a standard element. It's geometrically, it has some performance, but we don't really understand whether this is a good ventilation pipe or not, because we are architects, we are not MEP engineers. No problem, you will say. We just go online. We get all the information. No, all doesn't exist. This is when I got welcome here. I got called the Big BIM. But only 2 professors here, and they're both in the room, didn't ask me whether I teach them Revit. All the others asked me, do you teach Revit? No, I will not teach Revit. I will teach processes. Why? because there are some changes. You could already foresee them here. We do have a short summary of these 4 statements. We do have, for example, libraries. This is what many clients, building owners, ask for to use. Please use it. And really good companies actually put in their objects. You can upload, or they upload a file, and you can download it inside your software. You can scroll through the product families, and you have whatever, 262,000 parametric objects. Amazing. The problem is, how do you find the right one? I just had a look on this the other day, so it's quite fresh numbers. This is what is, you know, you cannot build a building out of that. If this is like you have 7,000 sanitary objects, toilets, it's nice. And then I thought, okay, 3,600 objects for construction material. I thought maybe finally I find the solution there. Sorry that that's my enemy. So we need to solve it. And then I figured out, yeah, almost 2,000 paint objects. This seems to be the market. Now, if we consider that the digitalization of the design, not of the construction industry, of the design people, engineers, architects design, is about having 2,000 color pots, paint pots. I think we are wrong. So what is the big problem? The big problem are our skills. Why? The thing is, when we have these 3D objects, click on that, it's really fun to look at. You have windows and this and that, and if you want to design your own window, nowadays with software, you really need to understand the software really well. If you want to have a parametric object in your own design, following your own, like the window profile, because you need it, because the building requires it, or the, what's the number 3 version of your dome? Thank you. If you really want to, there's no standard joint up there. You cannot download it. But you need to develop it with high skills about what does it mean in a holistic way. And when you stay, for example, in the wooden industry, there is simply known how you do a wooden joint. You know it. And therefore, for me, it's very nice. You have 60 joints, and if you when you can change them a bit, maybe you need 15 more next year, but it's not 2,000, because you stay within your logic. Now, that's the foundation. How to get out of that knowledge and understanding the tools. We went a bit further in this building that I just showed with the roof. How was the roof done? It's a bit blurred. We made a data circle. The data circle is, we had an idea, it needs to be a wooden roof. Why wooden roof? Because saving CO2 and having a lightweight structure. That was the preliminary thing. We could have done it in steel with an additional light sheet metal on it, but we decided, well, let's make a wooden structure. And the main important thing is we had a collaboration of different experts. It's not cheap, it's not easier to design this. We had 4 PhD students, 2 engineers, a couple of architects, wooden engineers. They all cost money. But compared to the construction costs, that was really cheap. You know, the engineering task is actually, and design task, it's not that expensive, 10% of the construction costs. It's not really much, but the impact you have, and particularly in the beginning, it's strong. So just one more spot out of there. You know, you created with a script, Python script, it's a scripting language. We created the geometry for the structural analysis and to create fabrication data, and if the structural analysis figured out there's some beam is not really holding, it would break. Then we had some modifications and generated the next data set. And it's already beyond a pure Rhino grasshopper freeform thing, because the 3D geometry is really just for the human to understand it. And the result is this: during construction, these are the beams, normal structure, very well known, but each beam has its individual geometric setting. How was that done? Now we have a video. Now I hope that works. Beep beep. Amazing. We had a wood construction company. Oops, that was at the end. That's not what I intended. Oh. They got the contract because they have this nice machine. So fabrication code was sent to them. Now I hope that the video will load. Will it? Kunstakademie, do you have internet? Someone didn't pay the bill. So, you see, it's moving itself. There's one employee. He's paid very well. He's a carpenter. You have this standard wooden object. Actually, they are a competitor of you in a way. It's Erne. And they're in Switzerland, and they sell their wooden elements, same like we have seen from Wendkunst and from your company. They sell it even to Germany. Now the robot changes the tool and is cutting off the end. That's him. They need to pay him a lot, that he doesn't leave, because other companies would like to hire. And there you see the trusses. Later you just look for this code word up there, then you know you can actually easily download. What is as well very new is that a classical, now I need to switch to the PowerPoint, that a carpenter is doing a YouTube channel. Which architect is doing that? No, it's so, you know, it's all for the publicity. No, they really got contracts now, and they become the turnkey contractor because they see a huge market. They hire the architect. They have their 5 preferred architects. They tell them which data they should deliver because they can oversee. They develop now their own facility management software. It's a carpenter company, and that's what they do. So it's quite interesting. What is the big advantage of that is that this carpenter has control of the things. And they can make, for example, buildings, whether it's architecture, I don't know. But they can promise to a client what they get. They make it quite nice. They employ an MEP engineer, they employ 2 architects, and they offer the vocabulary that we are used from the architect. What doesn't work though, and now we have the author here with Gunnar, thank you for being here. What we have as well in Switzerland, we have the big luck that we had economic success for the last 13 years. We didn't have a recession like you had 10 years ago. So we didn't jump into the BIM thinking, and therefore we can learn from the others, and we can overcome something like that. Why? There's now the 3rd revision of a classification system in Denmark. You might know it. You need it for cost calculation and all that to compare the one project to the other. When I say to overcome is, my critique on it is, why didn't we spend money from the side of the engineers and architects, why didn't we spend money to develop new processes to describe a building and its quality in a data level? We still love the 2D sections, they are brilliant, but why didn't we invest to better communication? It can be that we really need to argue, what is the engineer's aim and so on. So that's what I mean. We cannot represent a whole building with classification codes. And it never was the intention, but we thought 10 years ago, here, the same in Switzerland, still now, we think we can describe a building, we can make this digital twin. That sounds so romantic, we have a physical building and a virtual building. Forget, you can never describe the holistic complexity of a building in a virtual environment. But you can make analysis, you can make simulation in a virtual environment. Actually, more and more easy, like you really press the button and it tells you how many windows you have. That's so nice, how many square meters you have, what is the wind load. oh, what is the wind comfort, and so on. So, therefore, it is not so bad to have a description like that. DBCO. I know it's now the rework. I on purpose took the old one because we learned a lot out of that. And what I really, really learned is we forgot, hey, we could have here already an analysis of how to make the joint. No one considered that, not even me. I need to be self-critical on that 10 years ago. Like you can consider the window to the wall. How is it done? This is architecturally very critical. How do you put in the window into a wall? It's functional and all this stuff, that's really critical. Here we would have a possibility that software would tell us where is this problem coming up in my building. Because in a bigger building, either you make standard details. Ramböll made it all over the same. Probably you made it everywhere the same. No, I'm not. No, exactly. So, but it's mainly in your brain or in a nice file system. So you need to know it, and tools could help. Why don't we use the tools? And the other thing is how to make the joining the stuff together. You need to go on the technical level as well, and this is not really sexy, I agree. These are, for example, the attributes, just part of it from a wall in this so-called IFC file format, and we don't really like to look at it, but this helps us to communicate one issue to another player in the network. And again, when I've been a bit rude, I hope I haven't been rude this afternoon. We need to learn to communicate. It's really not sexy. But it helps us because machine could support it. And we don't need to go into this deeper thing. We have a development of digitalization. You mentioned even the Internet of Things and contracting, and your business field is actually quite dangerous. You are not only the turnkey collaborator, you want to do the whole thing. And then I'm lost as an architect. So I need to apply there. So, yes, but so now we go here. So look on what, and we are so happy in Switzerland, we can now go on purpose BIM. Why should I design in the BIM thinking in a way that I have only all data? I don't want to have all the engineering data. I want to have the critical information for my task because I want to take leadership. The second last slide, therefore, is please consider so-called common environments, and we have these nice graphics. It's the common data environments, plural, set up, which will help us. And I oppose such organizational charts where someone is the boss and you have some design management and you have somewhere. It's really not the way we should work. We do need to have a responsibility and all set up, but Hamburg, they've just finished a concert hall. There, the two main parties, very skilled in construction, the general contractor and the design firm, were not allowed to talk to each other because of such. They defined it, and you all know the mess. It's as well a public client. We have heard from OMA, all the public clients fail with their budget. The Airbnb was another example, a local example. And therefore, I really propose going back to the 60s. I'm not that old yet. This is by Quickborn team, an office design. How can you have more collaboration in an office in order to fulfill this? To have common environments, you have partnerships. Why don't you collaborate with a carpenter, make a new firm, in order to have what is called really a collaborative environment? And when you look at it, it doesn't look much collaborative. It looks like a standard boring office. But the thinking, the mindset, how they work, that's money-driven collaboration and perfect setup to create some innovation. That's what Google stands for. It's not social welfare, but they offer the best working environment. And Actually, that's what I want to have when joining. You know how to join the team, how to connect your skill with mine. Your skill with mine. That's the joint as well. That's why I started with the joint. Thank you.
Well, thank you so much.